Hi and welcome to Pre-Calc 20 with Miss Verity. Today we're going to be looking at adding and subtracting radicals. So to start off with, I would take a minute, fill in your perfect squares. These are very important to know. Pretty well the entire unit is based off of perfect squares because those help us simplify our radicals. So moving on, after you've done that, some terms to know when talking about radicals. So we've got a radicand, and the radicand is whatever is under your root. The index, that is the little number that sits out front. That's where last year I would have talked about your groups of things or your greatest perfect square. In this case, you'd be looking for perfect cubes. An entire radical is where you've got everything under the square root or the cube root or whatever root it is. And in this case, the cube root of 42 would be an entire radical. A mixed radical is where you have a number out front. It's fully simplified. It cannot be simplified anymore. So expressing entire radicals as mixed radicals. Last year we had kind of what I called method A and method B. So method A being where you split it and use your prime factors. So where 8 would really be 2 times 2 times 2. I would have got that maybe from a factor tree. And knowing that my index is 2, that means I'm looking for groups of 2. So I'd bring one of them out and I'd be left with 2 root 2. But this year, ideally, just because it's more efficient, what I'd like you to try to get and work towards would be using the idea of perfect squares. Because we know 8 is really the same as 4 times 2, 4 being the largest perfect square that goes into 8, while the square root of 4 is 2, and we can't do anything with the other 2, so it stays under our radical. Our next example, B, we've got 24x cubed. So again, thinking of greatest perfect squares that go into 24, I would say is 4 again. So that would be 4 times 6. 6, there's no other perfect squares that go into it. And sometimes x's or variables can be tricky. So x cubed is really x times x times x. That's the definition of a cubed. And so in this case, again, we have an index of 2. And so I'm just looking for groups of 2 with my x's. And same thing, I would bring one of them out. So my square root of 4 is 2. I said I have one group of 2 x's, so I'm bringing one out. And everything else that can't come out from underneath our radical is going to stay there. So I'm left with a 6x. And then example C. So in this case, the only difference is that we have a cube root or an index of 3. That means we're either looking for groups of 3, if you're kind of doing that method A, or your largest perfect cube that is a factor. In this case, I know my perfect cube is 27 times 2. That gives me 54. Well, the cube root of 27 is 3, and I can't do anything with the 2, so it's just going to hang out, stay under my radical. Converting mixed radicals to entire radicals. So basically what that's saying is I'm going to put whatever's out front back under my radical. In this case, we know in order to take something out from underneath the radical, we're taking the square root of it. So to put it back under the radical, we're going to do the opposite, meaning we're going to square it. So in order to put 4p back under, I have to square it. And I also have 7p that was already underneath my radical. Well, 4p squared, remember the squared is applied to everything. So 4 squared is 16 times p squared times 7 times p. 16 times 7, 6 times 7 is 42. Nope, that is not math. Wow. Whew, try that again. 7 plus 4 is 11. So 112 p squared times p is p cubed. And then again, the only difference here with a cube root is when we take something out of cube root, we're cube rooting it. So to put it back underneath, we are going to need to cube it. So negative 10 cubed times 2. Well, negative 10 cubed is negative 10 times negative 10 times negative 10. 10 times 10 is 100, times another 10 is 1,000. And negative times a negative times a negative is a negative, times 2. So that means, I should have my cube root, otherwise that is not correct. Cube root of negative 2,000. All right, so that was all our previous year stuff, so from Foundations 10. Now we're going to start the Pre-Calc 20 stuff. So that is adding and subtracting radicals. And the biggest idea with adding and subtracting radicals is you can only combine like terms when adding or subtracting them. So in this case, like when we are looking at x's and y's, we know we can only add x's together. So 3x minus 9x is negative 6x plus 8y. We can't add x's and y's together. Same thing goes for radicals. So your first step, in order to check to see if they're the same, is you want to be able to simplify it. So I'm going to turn my square root of 50 into a mixed radical. So I know 25 is my largest perfect square. So 5 root of 2 plus 3 root of 2. So now I've got my root of 2's are the same. So I'm going to have 5 root of 2 plus 3 root of 2. And just like x's and y's, the roots won't change. It's just my numbers out front. So 3 plus 5 is 8 root of 2. And that would be my final answer. So our next example, again, same thing. I'm just going to simplify. So I know 27 is 9 and 3. So square root of 9 is 3. Plus 3 root of 5 minus, if I'm thinking of 80, again, if you can't think of factors right off the top of your head, using your factor tree is fine. So if I go 80, I'm going to say 10 and 8, 5 and 2, 4 and 2, and then I've got 2 and 2. So notice I've got one group, and then that's another group. So I'm taking out 2 2's, so 4 root of 5, which would have been 16 times 5. Minus 4 is my largest number. That's a perfect square. That's a factor of 12. So square root of 4 is 2. 2 times 2 is 4, and I'm left with 3. So again, I can only combine like radicals. So I've got a root of 3 and a root of 3. And I've got a root of 5 and a root of 5. So negative 3 subtract 4 is negative 7 root of 3. Again, the radicals, nothing under the radicals is changing, just like when we had x's and y's. My x did not change at all. And then 3 minus 4 is negative 1 root of 5. Cannot simplify any further. There's no other like radicals. All right, and our last example has a variable in it. Variables, again, things are treated the same way with adding and subtracting. Has to be perfectly identical underneath my radical in order for them to be added together. So to simplify, square root of 4 is 2, and I'm left with root of c, minus square root of 9 is 3, so 12 root of c. This restriction is only because there's a variable, and it's basically saying c can't be negative because we know we can't take square roots of negatives. So now, anyways, now that I've simplified, my c's are the same, so that's good. I can add them together. 2 minus 12 is negative 10 root of c.